welcome. Today we will be doing Leetcode 18 for some problem. It's a medium, and with that being said, let's get right to it. So given an array of nums of n, return an array of all unique quadruplets, nums of A, nums of B, nums of C, nums of D, such that 0 is less than or greater than A and B and C and D. So they all need to be neighboring each other. The indexes need to be greater than each other, but D cannot be greater than or smaller than C, and vice versa. They all need to be distinct, so that all the indexes need to be unique, and all the summation need to add up to a target. So, and we're allowed to return the answer in any order, so that's good. This is also a hint to being allowed to manipulate the value, so to manipulate the array, so we can sort the input. So with that being said, we can take a quick look at this example. You got 1, 0, -1, 0, -2, and 2, and you got the target 0. So 4 values need to add up to 0, and here is your solution down here: -2, -1, 1, and 2. Where you got -2 plus 0 plus 0 plus 2 will equal to 2, and the same thing with here, with this last one. So looking at this problem, you can go ahead and try to do a brute force approach, which consists of 4 nested for loops that checks every single combination in this array. But first you need to sort, and then 4 nested for loops. The problem with this is it's going to be n quadratic as time complexity. And that's not going to fly. Obviously, in an interview, I feel like you can start with that approach, and if you feel comfortable coding it up, go ahead. But we're going to discuss a much more cleaner approach, which is a build up on top of Leetcode threesome. So I highly recommend you do that first, then jumping into this. But with that being said, since you're here already, let's go ahead and do this. And I would even argue you can probably go back and do threesome if you haven't done foursome, if you haven't done threesome yet. So this is a good problem to be aware of. So with that being said, we're going to sort the array of nums, which is going to be -2, -1, 0, 0, 1, and 2. And the approach to this problem is we're going to do a 2-pointer approach. But first, we're going to create 2 for loops starting at the beginning of the array, and then a 2-pointer, a left pointer, and a right pointer. The left pointer will be right in front of the second for loop pointer. So we have the first pointer I, and we have the pointer J for the for loops. And then you're going to have a left pointer that starts at J plus 1. And then you have a right pointer that starts at right at the end of the array. So length of nums -1. So that being said, I'm going to just erase this real quick because I'm going to go through the little algorithm, how it's going to behave. So first, we're going to try to get the summation of this guy. And the way we do this is we do -1, -2, -1, plus 0, plus 2. What does that equal to? That equals to 1, which is greater than the target. Sorry, I forgot to mention that the target here is 0. So greater than 0. So we're going to tell our right pointer to decrement by 1. So right now we have -1, -1, plus 0, plus 1. And that is equal to, that is equal to -2, which is smaller than the target. So we're going to tell our left pointer to move down. I am so sorry. This is getting late at night. this will be a -1. So technically, I'm going to backtrack here a little bit, and I truly apologize. I'm going to come down here. So since this is a -1, we're going to tell our left pointer to increment by 1, and our right pointer stays, giving that this is the same case. It'll be -1 plus 0 plus 2. Still a -1, which is less than, come on, there we go, less than 0. So we're going to tell the left pointer to increment again, and that's going to result into -1, -2, -2, -1, plus 1, plus 2, which is equal to 0. So we're going to append this guy into our result array. And now we're going to continue going, as long as while L is less than right. But once we hit a point where we found our target, we're going to move the left pointer and the right pointer to get rid of any duplicates. So we're going to tell as long as we are abiding by this rule as well. So there'll be another while loop here. And I can code this up. So if like current sum is equal to the target, we're going to append. And I'm skipping here a little bit just to go over this, but I'm sure you're getting the idea here of current sum. I'm going to highlight this so I can relocate it here. And then we're going to say while left is less than the right and nums at L is equal to the nums at L plus 1. We're going to tell the left pointer to increment by 1. The point why we're doing this, this is going to be duplicate work here. Let's just skip through. Let's do another one right here. Copied a little bit strangely, but so this one, it will be right pointer decrement because we got to go in the left, and we're going to tell the left pointer, right pointer, and here instead of +1 we're going to say right -1. So we're trying to compare its neighbor, and if there are duplicates we want to keep on moving across the array, so we want to keep going down and going up until we find the last duplicate. And then once we get there, we're going to do just L plus 1 and then right plus 1. That way we are not accounting any duplicates, and that gets rid of that problem. That being said, we're going to keep this code just here because I think it's going to come up here pretty shortly. And as soon as we get to this point, we're going to again do I'm going to choose a different color here. We're going to do the left plus 1 and R plus 1, but given that the while loop, the big while loop here is no longer valid, the J will be incremented. So we have J here. And also, to give you a heads up, we have a similar check for the I loop for loop and the J for loop, where if the I for loop or the J for loop notices that its neighbor is also a duplicate, it would continue and skip over it. So just as an FYI, it will make more sense once I go over the code, but for the sake of the theory, I hope you're following along, and I hope that this will make sense. I apologize for the confusion, but once we go over the code, it will make a lot more sense, if not already. So we're going to come down here, and we have a -1 plus 0, and our left pointer and the right pointer resets. So left pointer here, and our right pointer. If this can just go away. Jeez. Sometimes it works, sometimes it doesn't want to work. Okay. Plus 0, plus 2. Now we found our target here as well. So this is wonderful. We're going to come into a case where we are here now. So we're going to append this guy into this array, into this result array. And we're going to say, hey, while the left less than the right pointer and nums of L is equal, if we run into a case where they are equal, we want to increment our left pointer. If not, we're just going to skip over this guy, come down to the right guy. Hey, if our left pointer and right pointer are less than each other, left pointer is less than the right pointer, and then the neighboring one right underneath the current right pointer is equal to it. There's a duplicate that we want to decrement, but that's not the case. And we're going to come down to this guy now again. When the left pointer and the right pointer are going to be on top of each other. And unfortunately, that's going to cause the J pointer to execute, or the left pointer to no longer be valid. So what's going to happen is the J pointer here is going to come down to the next one. But like we mentioned earlier, the J for loop has a check where it checks, hey, if they are equal, we want to skip over this guy. So we're actually going to end up right here as being J, and then you get the left guy and then you get the right pointer. Given that this, again, violates this condition, we are going to reset this whole for loop of J. And we're going to increment our I pointer. Yep. So I is going to come down here. Yep. I come down here. J is going to come down there, left, and you got the right pointer here. Again, also the for loop for I has a check for duplicates, but given that -1 and -2 don't equal each other, the I for loop will execute. And then we're gonna try to compute this guy. Oh, sorry, it's not -2 anymore. It's -1 plus 0 plus 0 plus 2, which is equal to 1, and that is greater than the target. So we're gonna tell our right pointer to decrement by 1. So the right pointer is going to come down here. And now you have a -1 plus 0 plus 0 plus 1. And that is equal to the target. And we're going to append this guy into our result. So our if condition is going to kick in. And now we're going to go through this check again to make sure we don't have any duplicates as we move along the array. And nums of L does not equal the next pointer after the left pointer. 0 doesn't equal to 1, so this is not going to execute. This block of code is not going to execute. And the same thing for the right pointer. The right pointer doesn't equal, the 1 doesn't equal the 0, so this is not going to execute. But what's going to happen is our left pointer and our right pointer are going to cross, which violates this guy again. So what's going to happen is our J pointer is going to kick in, and this is all repeating logic itself. So I hope you're getting the picture here. And again, J is going to check its previous neighbor and is going to say, oh yeah, they are duplicates. I'm going to move the J pointer further, which is going to come down here, and then you got the left pointer right next to it, but the right pointer is out of bounds. So this is going to start over, and I would love to write up the whole output, but I think you're getting the idea. I highly recommend that you do write it up on your own, but according to the solution, we have met our conditions. The rest of the arrays or the possibilities are not going to meet the result. So I'm going to stop right here and actually jump right into the code. Once I write up the whole code, it's going to make a lot more sense, but for just a refresher, first we need to sort the array, declare our left and right pointers, and then we need to declare our result array, have the pointer, oops, sorry, I forgot two steps technically. So once we declare the result array, then we create two for loops. You got the I and J, and then you got, this is step number 5. And technically here, yeah, this is step number 5. Step number 6 is creating the if statement. But step number 7, I'm gonna be a little bit disorganized here for a moment. Step number 7 is to have the else if condition of current sum being greater than the target, which results in the R to increment, decrement, and then you got step number 8, else left pointer increment by 1, and then step number 9 is return the result. And I apologize for my handwriting. I know it's despicable, but again, we're going to jump right to the code, and it's going to be more distinctive and clarifying to what we're referring to. The time complexity of this guy is O of n cubed space O of 1. The reason why it's O of n cubed because you got 2 for loops over here, and you got a while loop over here. So we got 3 nested for loops, taking 3 nested loops, appending in each other. That's why that would result into an n cubed. So let's go ahead and jump right into Leetcode and start coding the solution up. All right, so we're gonna try to code the solution up right now. So let's first sort the array. So nums.sort, whoop. And we have the result variable being 0. And we're gonna declare our first pointer, kind of our first for loop in range, the I loop in range of length of nums. And then we're gonna have that check that removes any duplicates in case we run into it as we iterate through the array. So if I is greater than 0, we have started the increment from our first loop. We're gonna compare with its previous neighbor. If and nums of I equals to nums of I minus 1, we're gonna continue this. And then we're gonna go for the J loop, which is the second pointer technically in that, right? It's the neighboring of the I pointer in range of I plus 1, length of nums. And then we're gonna do the same thing over here. Okay, and we're gonna do J I plus 1 and J plus 1. Nope, sorry, J here. We gotta do J minus 1. And then we're gonna check, we're gonna create our 2 pointers. So we get the left pointer and the right pointer. I'm gonna make another white space here to make it for clarity, for readability. So it'll be J plus 1. This is the left pointer that stands right in front of the J pointer. And then you got the right pointer, which is length of nums minus 1, while L is smaller than R. If we're gonna do, let's do the current sum. Nums of I, nums of J, nums of L, nums of R. If current sum is equal to the target, we found the target. Let's go ahead and append those 2 indices, those 4 values into our array because they would want to return us an array of quadruplets. So we're going to do that. Like this. And we're going to check any duplicates. So if the left pointer is smaller than the right pointer still, and nums of L is equal to the nums of the neighboring right next to it. So, plus 1. We're going to tell the left pointer to increment by 1. And we're going to do the same thing here for the right pointer, but instead it's going to be -1 across the board. So, and then at the end, we're going to do left pointer increment by 1, and then the right pointer incremented by 1 as well, decremented by 1. So, taking a little bit, let's take a quick pause here and recap on why we're doing this. So, the reason why we are adding this while loop after we have found our target is to tell our left pointer and our right pointer to go ahead and iterate through the array until you match with the last duplicate you known. So if this was, again, going back to that example, -2, -1, like 0, 0, and then I had a 1 and a 2. So let's say the left pointer stopped right here. We had returned a result that incorporated this left pointer, and then as soon as our right pointer, let's say it's here, is less than, so it meets this condition, and the left pointer at this value 0 is equal to the next one. So I'm going to tell it, hey, just go ahead and slide over to L. And then the right pointer will do the same. In this case, it wouldn't apply because they're all distinct, they're all different at that point. But we're doing this last check to make sure that we are no longer considering a value we've seen before, which is that 0. So because we've seen a 0, there's no reason to see it again. So that's why we are doing that one more check at the end. This while loop, it just gets us the last, I'm going to type it here, last known, it's not how you spell last, known duplicate. And this one goes over, wow, I can't spell today at all, over the last duplicate. I think that's how you spell duplicate. Anyways, so once we have done that, we're gonna go ahead and we're gonna fly right here. We're gonna return result. So I'm gonna go ahead and run this solution. Oh, it's taking long. Oh no. Oh geez, I forgot. I jumped the gun here. How do I stop this? I can't. Anyways, so if you probably picked up, I don't even know. Yeah, because it's a complete infinite while loop at that point. Else if current sum is greater than the target, then we want to tell the right pointer to decrement by 1. Else we have reached a condition where the current sum is less than the target. So we're going to tell the left pointer to increment by 1. So that result that append. What did I mess up in here? What's wrong here? Result has no object. Driver. Talking about. I don't think it's a space. Yes. Oh, geez. That's fine. All right, there we go. Yay, here we go. So I'm going to submit the solution. It's going to be n cubed as our time complexity, and then our memory is going to be over 1. Oh, interesting. I think that's wrong, simply because we have a data structure that holds the array, and based on how many correct ones we get, it will grow in size. Will that be, if we look at our constraints, even then I'm looking at the constraints, and the fact that we are 10 to the 9th tells you that, yeah, this will definitely grow in size if targets are always met at each worst case. So hope that was helpful. I apologize for any confusions and mistakes, syntaxes, and technical difficulties. I appreciate the patience. I hope this was helpful, and best of luck in your preparations.